Population growth. Population growth is another application of geometric sequences. It can be used to model data. A typical question is as follows. A biologist is growing a culture of bacteria in a lab. She counts the number of bacteria in a dish every 6 hours. Below are her results. A. Create a general formula to model the number of bacteria at any time. In order to find the nth term, u to the n, for a geometric sequence, it is equal to u1 r to the n minus 1. u1 is the first term, which in this case is 125, and r is un, any term, divided by un to the minus 1, the term before, which is equal to 350 divided by 125, which is equal to 2.8. Therefore, u to the n is equal to 125, 2.8 to the power of t. T this time standing for time. It is t and not t minus 1 because our first time is time 0. B. Use the general formula to predict the number of bacteria at the end of the second day. At the end of the second day, there will have been 48 hours. So T will be equal to 48 divided by 6 because the time is taken every 6 hours. So that is equal to 8. We can now substitute T is 8 into the formula. So the number of bacteria, N, is equal to 125 times 2.8 to the power of 8, which is equal to 472,252 bacteria to the nearest bacteria. C. Determine when the number of bacteria will exceed 250,000. So we want 125 times 2.8 to the power of t to be greater than 250,000. Solve on GDC. Therefore, t is equal to 7.3822. But seeing t is every 6 hours, we need to multiply that value by 6. So t is equal to 7.3822 times 6, which is equal to 44.3 to 3 significant figures. D. Will the bacteria continue to multiply indefinitely? Explain your answer. In a perfect world, or an imperfect world, if the bacteria are harmful, they would continue to multiply indefinitely. But in the real world, the bacteria will die at some point. So they will not be continually multiplying indefinitely. So the answer is no, because bacteria will die.